Let's talk about how to build decision tree in this video. In order to build decision tree, we need to ask questions. And those questions has to be the right question. We need to know what question to ask, and we also need to know in what order we need to ask those questions. These two are really important things. If we ask right question in right order, then it will lead us to splitting possibilities quickly. It will lead us to less questions, less repetition, and it will also help us to keep the depth of the tree minimal. So basically we need to ask question that provides maximum information possible. Okay. Now let's see a couple of examples that will explain how asking right question at the right time will help us to build better decision tree. So first we are going to look at a bad example. Here, both of these examples are for loan application approval. So we will check some factors and we will decide whether the loan application should be approved or rejected. This is a bad example, and in this example, the first question that we are asking is whether the person who is applying has high income or not. Now, regardless of whether they have high income or not, the outcome is same. If you see, regardless of whether they have high income or not, we still have exactly same branches below, right? So this is not a right question to ask, because this question hasn't eliminated anything, hasn't eliminated any possibilities, and hasn't got us closer to the decision that we want to make. So this is a bad question. Let's look at another example where we ask right questions and that lead us to right decision very quickly. Okay, so the first question that we are asking here is whether they have good credit score or not. If they have good credit score, we immediately approve their application. Only if they don't have good credit score, we ask other questions, and based on that we will decide whether we want to approve their loan or reject their loan, right? So this is the right way to ask questions. But how do we systematically know what is the right question to ask and when do we need to ask them, right? In both of these examples, one of the question is whether they have high income or not. But when to ask that question changes the overall structure of the tree, right? So we need to find a way to systematically work out what question to ask and when to ask them. So the question that we ask has to provide maximum information that we know. In the previous example, whether they have good credit score or not is one of the question which provides maximum information if we ask it as a very first question, right? So how do we measure whether the question provides maximum information or not, right? We'll be able to ask many questions and we need to find out the question which provides maximum information, and that question has to be asked first, which means we need to somehow measure which question is going to give us the maximum information. So one of the measure that we can use to work out whether the question gives us maximum information or not is called entropy. Entropy is basically uncertainty associated with data. We'll see how it works a little bit later, but there are other measures that we can use as well. So one of them is called Gini impurity, and another one is called misclassification error, and there are many more. Okay, but for this example we'll just focus on entropy. So entropy basically defines whether the data set that we have has less uncertainty or high uncertainty. So this is the training data we have. In this training data we have 4 records and all of them have cat as a label. But on the other side here we have another data set, and in this data set we have 4 records and we have 2 classes, cat and dog, and both of them are evenly distributed. So out of these 4, 2 are cat and 2 are dog. But here all 4 of them are cat, which means if we randomly pick one of the records from here, we know for sure that it is going to be cat, right? So there is no uncertainty here. So because there is no uncertainty here, we say that this data set has low entropy. But on here, if we randomly pick one of the records here, then we have chance of it being cat or dog, we have 50-50 chance. The probability is 0.5 for it being cat or for it being dog. So this is the maximum uncertainty that you can have on a binary classification task, right? So we don't know whether it is cat or dog because each of them have 50% probability, which means this data set has high uncertainty, which means it has high entropy. So if it has high uncertainty, we'll say that it has high entropy. Okay. So that is what entropy is all about. If the data set have just one classification or a lot of them are having just one classification, then it will have low entropy. But if we have the data set that has evenly distributed labels, then that will have high entropy. So that is the basic principle. Now we'll see how this is going to help us to decide what question to ask. So basically what we need to do is we need to ask question in a way that it will split our training data into smaller subsets like this, where each of these subsets have low entropy. Okay, so if each of these subsets have low entropy, which means we somehow classified the data into a buckets where each of the buckets have more or less same labels, right? So that is what decision tree is trying to do, right? So we want to group data in a way that we'll easily be able to say whether a group of data in one group is whether cat or dog, right? So that is what we're trying to achieve. So basically, we need to ask question on a data set like this, such a way that it splits that data set into two smaller data sets like this. If we have achieved this, then that question is a good question because each of these subsets that we have created have low entropy. In here, we have just two records, both of them are cat, which means we have low entropy. And in here, again, we have two records, but both of them are cat, which means we have low entropy. So this is a good question to ask. Whatever question that we asked resulted in these two subsets, that particular question is a very good question to ask. So this is how we'll use entropy to decide whether the question that we are going to ask is a right question or not. Okay. Now, let's understand how training works. Okay. So because decision tree is also created using a normal AI model training process, we'll start with data. We'll have data set, which is a label data set. We'll feed in that to our training process. And this training process is going to have feedback mechanism using the measures that we have seen previously. It could be entropy, Gini impurity, or misclassification error. One of the measure will be used to guide the training process. And at the end of the training process, we'll have a decision tree. And for the training process itself, there are many algorithms like CART, ID3. It doesn't matter what algorithm is used. We'll use one of those algorithms for creating this decision tree using the training process from the data. Okay, so this is how a decision tree is created from training data. Now, let's look at when it is good to use decision tree and when it is not. Decision tree is transparent, which means it is very easy to interpret and explain the decision tree. We'll be able to explain what is going on in the decision tree, and we'll be able to explain why it has come up with the decision that we see. Okay. And it works really well with both numerical and categorical data. Okay. We can use both numerical data and categorical data to create branches. Now let's look at some of the disadvantages. So one of them is it is very hard. It is computationally hard problem to come up with optimal decision tree. Okay. So what we need to settle on is good enough. We need to go with good enough decision tree rather than the optimal decision tree. So that is one downside. Overfitting is one of the common problem with decision tree. The decision tree will learn the training data so well that it will not be able to generalize on unseen data. Although this can be addressed using many techniques, one of them is called random forests. This is still one of the problems that we need to keep in mind when working with the decision trees. Okay, that is all I wanted to cover in this video. I hope this is useful. Thank you.